Hello everyone, good afternoon. Hope you guys are doing good. Uh, Please confirm once whether my screen is visible and am I audible loud and clear so that I can start the session. You can say yes. Yeah. Thank thank you. Thank you. You can say yes, no over the chat. That should be fine. Okay, fine. So today, okay, in last session, what we have discussed, I think, let me go through the notes once again. The batch name was 2nd June and it was, I think, assignment. I have given assignment. Yeah, I've given assignment as well, linear regression assignment, I think. May I know how many of you have tried and done this successfully? Any question in this assignment?
Yeah, I have tried, and one more thing, is there any disturbance from my side?
Distance with, sorry, I didn't get
Disturbance.
distance. No, 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 no. There is no
Okay.
distance.
Yeah, I have tried, but I don't think it's correct. I have tried the flow, actually.
Okay, if you don't mind, you can share your screen. I could
Yeah.
help you, like, and everyone can see how she is doing and what mistakes she is doing, right? And so that it will be helpful for the others as well. We'll spend another 15 minutes to do complete this assignment because from here the confidence will get built. I don't know how many of you tried, but Trumula seems like tried, then it's good. Thank you, Trumula. And like it's good that you are trying that things from here. The yeah, like things will be get more complex because going forward we are going to build a hybrid model in the sense of in single model linear regression some part, logistic regression some part, and some other model also we are going to combine. But if your single model itself is not don't know, then how you can think this is going to solve there, right? So yeah, so just a minute, hold on 1 minute and let me go to your screen.
Yeah, hi,
Yes, hi.
yeah, yeah, we got it. Mean square and R value.
Okay, okay, just a minute. Now, yeah, Tirumala, now you can go ahead. Everyone, I would say, please watch her screen, what she is trying to say. Yeah, please run one by one. And why you define first adjacent R square function is like the last step, right? Evaluation is just evaluation, right? So I think we should
Yeah.
define this later. But yeah, anyways, leave it. Go ahead, run this code. Ready to be run. What do you understand? Wait. Did you understood these features first? This is the primary job of your data scientist. What these features
Yeah.
is saying, CRIM is crime rate. In that society, what is the crime rate? Indus, CHAS. Did you get a chance to look into this feature? What these features
Yeah,
are
I
saying?
have gone through the
What these
what
features are
the
there? Can you
lyrics
please?
of this
Yes.
from Google, like
Yeah. So see, guys, if you are solving any kind of problem, please try to understand what the features are, what these features are saying. That will be good.
what is. I've gone through somewhere. I have stored
Okay.
that thing.
Okay. So if you guys having any problem to understand anything, go to the boss, go to like, okay, let's suppose Boston data set. And there is a website which called Kaggle. How many of you heard
Oh,
about
yeah,
this website?
Kaggle.
Kaggle. So here
I've
you
got
guys can do the competitions as well. You guys can, it's a very good website. And one of my brother, his name is Abhishek Thakur. If you get a chance over the YouTube, he's very popular on the YouTube. Uh, Abhishek Thakur, yeah, this one. This one is his official website, official YouTube page, and he's very popular YouTuber. So he is Kaggle master. It seems like he used to do many Kaggle experiment and all the sort of thing. So I would say whatever problem you are solving, go to the Kaggle website like Boston, and here you will get each feature definition. Can you see this? CRIM, capita crime rate by town, ZN proportion of
Rajesh, I am sharing the screen.
like I am also sharing my screen. I think.
No.
Yes, you have to pin that. You have to pin that my screen. Okay, let me reshare once again. Now my screen is visible. Yeah.
Yeah.
Okay. So what I was saying, like each features having their own definition. CRIM. I was talking about first this part. Abhishek Thakur. He is very popular. Like any kind of Kaggle problem you are trying to solve and you want to get help, you can watch his video. He's very popular in this case. Kaggle competitions means he's the master. So CRIM, what the CRIM features does, what is Indus feature does, JAS, NUX, RM, each feature definition descriptions has been written here. Can you see this? So I would say like whatever problem you guys are solving going forward and whatever data set, I think Trumula, you only asked for data set, right? And from where I downloaded data set,
Yeah.
from here only I downloaded the data set. So you can get the data set, you can get the code, everything. See, complete code is also written. But the thing is it's not about the code, it's about thus understanding the problem. That is also matter, right? So that's what I always prefer. Don't use the code, try to understand the problem from here, note down this definition and description about the code, about the features, what these features are saying, and try to understand, try to make your understanding about this feature, then only try to go to the go for the solution, right? So yeah, that's what I was saying. Like this is the website from where you can get the uh, these things. Yes. Now go ahead. Now go ahead. You can carry on. Yes, Tirmala, you can carry on.
Is my screen visible?
Hold on. Yes, your screen is visible. Yes. Huh. So these features, I would say, just go ahead with these things. That website, then only you can get it out. Yeah, run that code. So here you are loading the data set. Yeah, run this. And here you are trying to fill NA with mode. May I know why you are filling the ZN feature with mode? You're on mute.
To take the value, like sample value we need to take, right? So we have just selected the most frequent value.
So what is
So
ZN? ZN is a categorical data or continuous data? Go ahead and code. No need to come here. Just go in code and just explain the things. Why mode? Why not mean? That's my question. And may I know what is the ZN feature? ZN is a categorical or continuous data? Go above. No, go
Sure.
above. Go above.
Okay.
Where you show the data set. And see, ZN is the continuous data set. So continuous data never get filled with the mode. It should always fit with the mean.
Okay.
Okay, so you did a mistake there. Note down this point, guys. Whoever are not doing the practice at all, for them, just keep these pointers and please try to do this assignment. Yeah, come down now. So this is the mistake. You did it. Age, you did again mean. Age को तुमने mean से forward किया. That's fine. Indus, what is indus? Again, it's a continuous, so mean. So I don't know why you made ZN for mode. That you can check it out. Now come down. What you are trying to do here? You are trying to plot the graphs. Okay, come down. Bell curves, yes. So it's a scattered plot. It's a scattered plot. Come down.
No, it's bell.
Okay. It's a bell curve. So you are going to check the PDF, probability distribution function. So PDF in the sense of like how the distribution it is. So with this distribution, wait. Let me explain this part. So with this distribution, we can clearly see wait. With these distributions, we can clearly see like CRIM, ZN. This is not standard distributed data set. What do you mean by the standard distributed data set? If any data set or normalized distributions data set. So standard distribution data set means whose standard deviations is standard deviation is 1 and mean is 0. And it will always follow the bell-shaped curve, exact bell-shaped curve. Can you see this? ZN is not a bell-shaped. Can you see this? It's a right skewed data. Yes. Here also Indus may, this is not seems like a bell shape, right? Here also there is some skewness. In Chaz also there is some skewness. Can you see this portion? And also can you scroll down? Just try to understand. Here also see A section may there is some left skewness. RM is properly following the bell shape, not completely, but yeah, it seems like it follows the bell shape curve. So I can say RM is the normally distributed data set or standard distribution data set. NOx is not a like you can say it's not a normally distributed data set. It's not because it's not following the bell shape curve, right? DIS again, it's a right skewed data set. Come down, my dear. Yeah, you can see tax is also not normally distributed, and this features is also left skewed. This feature seems like properly normally distributed. This is called outlier. I will talk about these things later on, but there is some skewness. Come down. Here also it's right skewed. Here also there is some skewness is there. Yeah, we understood there is some feature which is called there is some skewness. Now, what we are trying to do, you in the cell number 38, she is trying to remove x and y. What is x? X is independent feature. Y is what? Dependent feature. So she is going to make input and output, right? Correct me, Trumula, what your understanding with this, doing these things, not just to do the copy pasting of the code. I would request you guys to understand the code as well before running the code. Yeah. So here you are trying to make a independent distributions of input and output, right?
This y-axis should be this median value, and x-axis should be vary instead of this median value. What we can expect to.
So how you understood MEDV is the output?
Yeah, that's just they told we need to find the price, right?
Yes.
So I just took the data in. It is a median value. It's just like similar to price only.
Very good. It's a good understanding. It's a very good understanding. But I would request again. So if let's suppose in this problem statement there is a no feature where multiple price is there, multiple price features is there. That's what you understood. But what will happen if the two or more than two features where the prices has been there present? Then in that case you might get confused, right? So always try to understand the problem. What is MEDB? Even I don't know. the problem statement, what is MEDB. So I always go to the website. I always try to explore because it's a very well-known data set. This data set is already available in the many websites. So you can understand what these features are doing. Yeah, carry on. So that's a part of the going forward. Whenever you will solve the problem statement, first try to understand what the data is saying. That's a very basic, fundamental goal or fundamental point of data scientist roles and responsibility that I have been explained. Yeah. So you are going to drop your X and Y. Now, again, you are trying to do the scatter plot. Yes. So we can see with the scatter plot MEDB, we are trying to plot a scatter plot between the MEDB and CRIM, MEDB and ZN, MEDB index. So we are just checking how my input features are getting distributed with respect to the output, right? Right?
Yeah.
So here you can see just trying to get some relationship. That's all. Yeah, go ahead. Go ahead.
So in this
Huh.
plots, I got to know that some linear relationship between RM and this
MEDB.
MEDB.
Yes.
And one more thing I found this one,
Yeah.
but this is inversely proportional.
Yes,
That is
yes.
directly proportional.
But it's following the state line, right?
Yeah. Yeah.
Okay.
Oh yeah, I have written my observations.
Nice. Come down. Yeah. So here what you are trying to do? Can you please explain to everybody?
Here I need to find out EIF factor.
Why VIF? What is VIF?
That when collinearity will be there, we need to, like how much collinearity is there, we need to find out using.
But before VIF, you did a standard scalar as well. What is that?
This one I didn't understand.
Okay, so let me make you guys understand. Anyways, this we deserve a separate class, but I'm just trying to make you guys understand. So we have seen the PDF. Can you go scroll down a bit? Yes, scroll down. No, not sorry, scroll up. Scroll up where the PDF was there. Bell shape. Bas leave. Bell shape wala. So you can see there is each feature having some skewness, right? There is some skewness is there. So it means like this data is not normally distributed. So in order to make the data normally distributed, what we can do the standard scalar. Inside of standard scalar, what we are trying to do? We are trying to make distributions of data set in standardized format. Means we are going to whatever variance, whatever mean will be there, we are trying to convert that mean and standard deviation as a mean is equal to 0 and standard deviation will be 1. That things we are trying to do here with the standardization. How these things is being done? Okay, how these things is getting done here? That part we will see later on. But as of now, just go to the standardization section now. So yeah, in this section, cell number 48, she is trying to do first standardization. Means in standardization, what she did, she convert whole data set in some scale so that mean will be 0 and standard deviation will be 1. Okay. Do you want to see? Okay. If you want to see, can you run the cell number 48? Run the cell number 48. Name error. X is not defined. It's above cell. You missed it to run. Run all the cell one by one. Now create one more cell. Wait. Create one more cell here, new cell. That is Control M A or Control M B. Okay. Press Control M and release the code keyboard and then press A or B. And type here X scale, capital X underscore scale. Execute this. Execute. You can see your X was what? X was something like 1, 2, 11, 12, right? Can you go to the data set? Above. Go to above. हाँ go see here हाँ go above थोड़ा और ऊपर जाना go above हाँ this section out of go above this section CRIM can you see the 0.0632 ZN18 was there now it completely convert now come down this axis scale wala portion now see the complete transformation of the data set has been done in such a way so that the mean become a 0 and standard deviation become 1 come down no not here axis scale what you this one so see this each feature got normalized now automatically using the axis standard scaler now what is the VIF is to check the collinear as she mentioned she's clearly mentioned like there is a n number of features to predict the output right so it might be possible some features is collinearity between the other feature let's suppose my age is very collinear with the height means or you can say my height is very collinear with the age so instead of considering these two feature why cannot consider only single feature either height ko consider kar lo or age you can consider why you are going to consider these two features unnecessary you are in two things number one you are going to increase the computation power computation cost second thing your model will get overfit because see if you are going to teach your child same thing if you're going to teach your child same thing with the two way your child will get confused right and both the way are same so your child will get confused so why you are going to make your child as a confused machine is the same way so that's what we are going to remove some of the feature which features are not important so how we can understand which feature is not important or how we can say which feature is the collinear so for that, we are going to we are going to create VIF variance influence factor C created in the cell number 11. So so here in line number 49, cell number 49, she is clearly shown the VIF of all the features, and we can see VIF of the CRIM, VIF of the ZN, VIF of the Indus, VIF of the CHAS, all the features has been there, and we can see RAD. Can you see this RAD? RAD feature. Yeah, this feature seems like highly collinear. Can you see the 7.8 VIF score is the 7. Any feature whose VIF is above 5, we should remove that feature. Did you guys understood? So you can see observation here are two features which having the VIF is more than 5. And she is mentioned as well, 8 or 9. Yeah. So we can remove these features, right? So she have not removed, but I would request you guys to remove. Otherwise, your model performance will be not good. So it's a very good practice. First attempt, create a model, whatever data set you have. Second attempt, do some kind of pre-processing and cleaning. This is the way how you are teaching your child, right? First attempt, you are teaching your child, your child went for the examination and your child didn't perform well. Second attempt, what you will do? You will follow the same strategy to teach your child? No, you will change some way. Okay, now this time I will make him or her as a fun way to teach her lesson or his lesson, right? So what I will do, I will remove some of the chapter which is not important for him because I can see she or he is not able to digest complete chapter. So why I cannot remove those chapter which is not important for the examination? Same thing we will do in the next iterations. Did you guys understood? This is the called data scientist job. Okay, come down. So here what we see did in cell number 51, she is going to split the data set into plain test. And what is the test size she made? 25%. Okay, so here she is mentioning linear regression in cell number 55. Just try to understand she is mentioning linear regression. She is going to create a model and she is going to predict the model as well. Can you see this here? She is trying to do the prediction and she is getting the score. Can you see this? The score is 73%. Train score is 73% and what is test score? You will not create a test score. So I would say regression dot score and here you can mention X test and Y test. You will get a test score. Okay, she not didn't complete that part. No, you have to run that one. Okay, so test score you can get it. So I would request Tirumala, you did this much well and good. What you can do, you can remove those features. We have seen like two features which VIF is more than 5. Remove those features. Go to the code. Stay in the code. I will explain that part. So remove those feature RAD and the one more feature was there, right? In the BIF section, remove those feature and try to create again model and just check your score is getting increased or not. Did you understand what I said? Yeah.
Yeah.
So yeah, she created a model, she did a predictions as well. Very good. Well, so now we can create an API as well. I will show you after the another model one, like we have a different model in the pipeline. Once that model has been created, then okay. So now my question with everyone, you can say by yes on the chat. Did you guys understood what we did here? Any questions? Tirumala, you can also say, like if you have any question, any doubt in these things, you did it.
Yeah, this
Yeah.
I have one question.
Yep.
Mm,
I think I talk about region, lasso, and elastic, right?
Yeah, yeah.
Yeah.
No. One value I got, it is, I doubted that whether I'm doing correct or wrong.
Yes, sir.
So that one I wanted to ask.
Yeah, please.
Okay, in end of the session I'll ask.
Sure, sure. No worries, no worries. Okay. Nice job, Tirumala. Just try to be more research oriented now. These are the things you did, whatever I delivered, right? Now, what you did by own, understanding the problem. You didn't understand that part only. You didn't do the well. See, I used to speak apparently in front of all, like, okay, you did good thing, but the thing is that for which you are here, I mean, data scientists are here. You didn't do that part only. Understanding the problem statement, you didn't do that. It's kind of hard-coded development you did. I shown 2 plus 2 is a 4, you did it, but you didn't understood the problem statement. So I would request from the next time onwards, please try to understand the problem, understand the solution. Understand, instead of coming with the solution, try to understand the problem as well. So that will be helpful for you also, right? Yeah. Cool. Others, what about others? Others are listening Satnarayan Bhagwan Katha or what? How many of you tried at least? I don't think so anyone has been downloaded the data as well, right?
Hi.
Yeah.
Hello?
Yes,
Yeah, we
sir.
tried and we completed, but with the help of some Copilot.
Copilot, okay. That's fine. Copilot, I don't have any problem, right? But at least you should show the. Did you understood the problem?
Yeah.
Okay. Sure. No worries. Now what we are going to do, I would request you guys please download one more thing. The 14, I have uploaded a video as well, I think. Yeah, the 15, I'm going to talk about logistic regression. Today we are going to discuss about another model which is called logistic regression. So for this, you guys please download July.
Hello?
Yes.
Rajesh, could you please look into this? I will present now.
Sure. Please.
Just have a look in the autopilot and Copilot and you did something.
Yeah, please share your screen. Yeah, everyone, please follow these things. See, AI, you have to work with AI. You can't deny the AI solution. That's always I used to say. If you are going to deny the AI solution, you will be behind of the in the market. So please try to understand. Yeah, sure. Okay. So you see, he's downloading the data directly from the URL. Can you see this? Directly, he's down line number 11. Everyone, please watch carefully. He's directly downloading the data. What Tirumala did, Tirumala downloaded first and then load the data CSV file. Now he is directly downloading the data from this URL. Can you see this? Yeah. Now go. URL opener. This is the function from where he is trying to open the data. And now see pd.data frame. Now see, he is doing the same job. Right. Yeah. Here you are going to remove. Okay. In your case, price was the column. Was it?
What again?
In your case, in your data set, price was the column available because I have not seen in Trumula data set price column.
We have given like, why it will determine the price alone, like, for testing.
No, my question was, ki, whatever data you loaded, did you print it? That's what I always try to say. Instead of you have a code, right? That's fine.
Yeah.
Can you open these things in a Jupyter notebook and just run one cell, what the cells are saying, what this code is doing? Then you can understand and then come up
Okay.
with the Python file. Because in this you can't understand, you can't visualize what data is saying.
Okay, the changes in the data.
Yeah, so you cannot understand this thing. So what I would suggest, wait, do you have Jupyter notebook? Can you open directly in this directory? Oh, wait, I will tell you. Click on plus symbol. There is a plus downside. This section. Click on that. New terminal. Or select working directory. What is your working directory? This one, app, local, program, Python 11, Python.
APY.
I don't know. Okay, come down. Leave it. Press escape. Escape button. Come down. Terminal. Niche terminal. Scroll down. Complete scroll down. Type here Jupyter notebook and create a separate folder for all the jobs. Otherwise, you will get confused to find what data is. Jupyter notebook. Then, okay, do you have Anaconda installed? I don't think so. You have Anaconda installed in the system. You installed? Can you open your Anaconda? I am not seeing your Anaconda has been installed. Otherwise, base environment should get activated. No, it is not there. No. First install Anaconda. Okay.
Okay.
First install Anaconda and then create a Jupyter notebook. How similar to Tirumula did. Now, afterwards, next time means like once we will start the API, we will convert the Jupyter notebook into the Python file. That we will do. That's our exercise. We'll do in the next time. But as of now, just do whatever things you are doing, you guys are doing. Please try to do all the things on the Jupyter notebook. So that in the Jupyter notebook, the benefit to use the Jupyter notebook is what? You guys can understand each line of code. Like what this code is doing, what that code is. Like how I shown the X scale, right? Just now I shown in one single cell, I print X scale. I show the difference between the X and X scale data. So that like this you can scan this. Yeah. So yeah, seems like you also tried. Nice. So today we are going to discuss logistic regression, right? So share copy link. And I would request you guys, please download this repository. Please download this repository from your master sheet, day 15, logistic regression. Once it get downloaded, do let me know. Okay, my screen is not visible. Oh. Okay, now is it visible? Please download this repository, guys, day 15, and then I will come forward for this. Now we are going to discuss about logistic regression. We understood the linear regression. Now we are going to discuss about logistic regression. Yeah. Once it downloaded has been done, do let me know. And extract your logistic regression part like this. Okay,
Rajesh is asking permissions.
okay, it's not enough permission. Just hold on. Try now.
Yeah, no.
Yeah. So once it downloading has been done, then go to your folder will be look like this. Extract that folder and you will get this kind of files. Okay.
Analytics.
No, done. Downloading done.
Yes, from my side.
Cool. Nice. Very good. So, so now once downloading has been done, open your Jupyter notebook and navigate yourself into this directory where you downloaded. And yeah, do it. How I am doing. See, observe me. So this is my Jupyter notebook. Currently, I am sorry, Anaconda. And see, if you have Jupyter notebook installed, in front of your Anaconda, sorry, command prompt, you might see base here. In my case, it is showing Anaconda 3 because I am using different flavor. I'm using Miniconda, not Anaconda. You guys are using Anaconda. That's what in your case you will see here base environment. But in my case, it is showing Anaconda 3, right? So don't worry, both are same. So, but it should be there. Something it should be there. So if it is not there, means your Anaconda has not activated yet. Okay, so what I'm trying to do now, I'm trying to run D folder. I'm using something here. And how many of you configure WSL? I used to say from the long time, the Windows subsystem Linux. How many of you configured in your system? A single thing, very common thing of WSL has to be configured in your system because you guys are using Windows. So I'm saying from the long time. And when I will start deployment, that moment, if you guys face problem, don't say like what is going on in my system, it's not happening or something. Please try to install WSL. Okay. Because see, what the benefit will be there once you configure WSL, you can play with any kind of terminal. Can you see this in single terminal? If I want to go to the Ubuntu, see, in my system only Ubuntu is there. In Windows system only I'm using Ubuntu. So please configure WSL, otherwise problem. It is very bigger problem. So yeah, so go to the D drive because my all job is running on D drive. In your case, it might be E, F, G, H, whatever it is. Go ahead. Jupyter notebook. Open your Jupyter notebook. Okay. Jupyter notebook open karo. And it seems like my Jupyter notebook. Oh shit. If it got closed, don't worry. Copy this URL and paste it in your browser. Okay. Now you can see everything is there. Now what I can do, my all folders are inside of my Rajesh and my classes. See how I structured my folders for my jobs. Can you see this? These are the blockchain. When I used to take a class of blockchain, I have prepared a complete blockchain tutorial on this folder. Images, whatever images are learning for my learning purpose, whatever I am learning every day or wherever, I used to keep inside of my disk directly. Movies, my classes, portfolios in the sense of I have my own portfolios where I used to keep update my things. I used to keep in these things. Projects, like I used to get the freelancer projects and all the sort of things I used to keep inside a project. Rasa, Sasank project, these are different. So please try to maintain this kind of folder. So tomorrow, if someone will come, okay, you are only coming. Rajesh, yesterday class, I missed it out. Can you please help me to get the class notes? I will not search here and there. Like, I'm sure what was doing. Like everyone is doing with the C drive. No, it's not a right way of doing these things. Structure your folders. It's a very basic thing of management of your code, right? So from here only things will get built up, not about just learning the things. Okay. So I have to go July 5th. Okay, your batches inside of 1st June, I know, but I kept my all linear and logistic regression in July batch. So I will not do the copy paste again. So I will go here, logistic regression, open this notebook. Okay. How many of you are able to open the notebook? Please say yes in the chat. That should be fine. Yeah. Thank you. Okay, so if you are able to open your notebook, that should be fine. And now, again, I will repeat this stage, which we learned already in the linear regression, but still it seems like you guys not followed these stages. See, if you guys followed, then you should understand the problem statement. See, in the very first step I have written, whenever you are dealing with any kind of machine learning problem or deep learning or computer vision, AI, NLP, whatever problem, first follow this stage. First start data collection, which you did. You collected data or Boston data set, you collected. Now data description, you missed this part. What the data is saying, you didn't ask this question with yourself. So this is a blunder mistake you did. Third step, you didn't follow, right? Data description, a story, what data is all about and the features present in the data. That part you missed it. Performing both statistical and graphical data. Yes, we did it. Data transformation and derivation. Yes, data transformation also did. Like standardizations, we did it, right? Data transformation. Then selection of machine learning algorithm. Yes, we did. EDA, data standardization, normalization, we did it. And creation of data, train and test data set, we did it. Model training using the machine learning algorithm and tested above. Yes, we did it. And then calculation of model accuracy, both training and test accuracy. You did for training through Mula, but not did for testing, right? So this is the mistake you did. Note down this point. This from going forward, whenever I'll give the second assignment, please follow these things. Don't do this mistake again. Do new mistake. I love to make a newer mistake, not same mistake, right? So please come up with the new mistakes. Hyperparameter tuning and achieve the better accuracy. That's the thing. Then saving the created model and the deployment strategy. I have not talked yet. I will talk about these things once our linear regression and logistic regression both will get completed. Then at the same time, I will show you like API. I will make you guys familiar with the APIs building and all the sort of things. But as of now, just try to understand this part. Yeah. And then production deployment testing, finalizing the retraining approach, and then logging and monitoring and dashboard or monitoring, logging. Here the Tableau and Power BI things will come into the picture. But as of now, just leave this part and then stop the process, right? So did you guys understood now the life cycle of any kind of data scientist problem or machine learning problem? Your job is not to make 2 plus 2 4. Your job is to understand why 2 plus 2. Why not 2 plus 2 become 5? Can be possible, right? Because in AI, everything is possible. Okay. And now let me talk about introductions of logistic regression. Let me go ahead with the logistic regression is similar to the linear regression only. Don't worry at all. But linear regression is used for regression problem and logistic regression is used for solving the classification problem. Okay, classification in the sense of like male, female, true, false, pass, fail, first, second, third, this kind of category divide, right? It's not about the. Now you might say, Rajesh, regression stands for regression problem, right? I understood completely. I'm with you. Now, as logistic regression algorithm is solving the classification problem, then why it called as regression? Why not anything else? So I will give this answer. Keep with me. So in the linear regression, let me make my okay. So in the linear regression, the type of data we deal with quantitative data. Quantitative like the price, it's a very real number. Quantitative means real number. Okay. Whereas we use classification model to deal with the qualitative data. Qualitative means like first, second, true, false, pass, failure, this kind of qualitative data or categorical data. And the algorithm used for solving the classification problem first predict the probability of each category of the qualitative variable as the basis of making the classification. So here is your answer. See here, let's suppose we have a two class, pass or fail. Okay. So now this is categorical data. Now what we are trying to do with the logistic regression, we're trying to calculate the probability of getting pass and failure. Let's suppose this is 68% and this is like 22%. This is like 22%. Huh. No, 32, I think. This should be 32%. Okay, so 32%. Now just try to understand this two part. See, and based on the probability, we are going to check what is the class. So this probability still is a linear number. Can you see this? 68, it can be 68.2, 68.3, it can be 32.2, 32.3. So we are still calculating the probability, and probability is the real number. That's what it is called regression. So here, very clearly it's mentioned, the algorithm used for solving the classification problem first predict the probability of each categories of the qualitative variable and as the basis of making the classification, and as the probability are continuous number, see, probability is what? Continuous number. Classification using the probabilities and also behave like a regression model. Can you see this? Also behave like a regression model. That's what logistic regression is, one such type of classification model which used to classify the dependent variable into two or more classes the category. Now question is, why don't we use the linear regression for the classification problem? Means still we are calculating the probabilities only, right? And probabilities is the real number. Then why cannot go ahead with the linear regression algorithm, right? So let's suppose you took a survey and noted the response of each person as a satisfied, natural, and non-satisfied, not satisfied. Let's map each category like satisfied in the sense of 2, natural is 1. So we noted how many of people are getting satisfied. Satisfied is 2, natural is 1, and not satisfied is 0. Okay. So just try to understand. So, but this doesn't mean the gap between not satisfied and natural. See, this is the number, right? This is the number. Same as the natural and satisfied. So there is no mathematical significance of this mapping. So we can also map the category like satisfied 0, natural 1, not satisfied 2. So seems like we are just going to do the label encoding because machine will only understand the label. And it completely fine to choose the above mapping, and means you can map like this as well or this as well, but always go ahead with the sequencing. And if we apply the linear regression to both type of mapping, we will get a different set of prediction, right? And also we can get the prediction value like 1.2, 0.8. Like 1.2 means what? Satisfied or natural? I don't know because it's a 0.2. We can't understand this part, right? So 0.8 is what? That's what we can't use the linear regression here to solve this kind of problem. We are going to use logistic regression. So did you guys understood why we can't use linear regression? We have to use only logistic regression, right? Now just try to understand logistic regression is one such regression algorithm which can be used to perform classification problem. Can you see this? I clearly mentioned which is going to use to perform classification problem like first, second, third, pass, failure, true, false, male, female. This kind of category, if we are going to classify, then we should use the logistic regression. and it calculates the probability that a given value belongs to the specific class. If the probability is more than 50%, it assigns the value of that particular class. Else, if the probability is less than 50%, then the value is assigned to the other class. Therefore, we can say logistic regression is act as a binary classifier. Means what I'm trying to say, let's suppose we have a coin. We have an unbiased coin. What do you mean by the unbiased coin? So if you are going to throw this coin, at a time either head will come or tail will come. At a time, head and tail both will not come, right? So that type of coin is known as the unbiased coin, right? So what we can do, we can get this coin and we are going to throw this coin, and the chances of getting the outcome is what? Either head or tail, right? So what is the chances of getting head? What is the chances of getting tail? It can be 50-50%, right? So it is saying, this algorithm is saying, if your probability of getting any event is more than 50%, then we can predict that if we are throwing the coin, let's suppose head chances is occurring as a more than 50%, then other always will be less than 50%. What I'm trying to say, let's suppose head ka probability is more than 50%, then obviously tail probability never become more than 50%. It will always be less than 50%, right? It will always should be less than 50%. So what I'm trying to say, if any event probability is more than 50%, then we are going to mark that class is belongs, that output is belongs to that particular class. So same thing has been written here as well. So it calculates the probability of that a given value belong to the specific class. If the probability is more than 50%, it assigns the value in that particular class. Else, if the probability is less than 50%, then the value is assigned to the other class. Therefore, we can say that logistic regression acts as a binary classifier, right? Now, working of the logistic regression. Let's do some mathematics now. Okay, be ready with the mathematics. Clear all diagram and try to understand the mathematics, right? That will be help you. Again, I'm saying it is not like that without mathematics you can't stay here. You can, but at least you should understand how the libraries are working. Backend way, what techniques they are using, right? So working with the logistic model for the linear regression, the model defined like this equation, right? From here only we will calculate the logistic regression. How many of you are aware with this equation? Say yes.
Yeah, line.
Fine.
Linear regression.
Yes, in the linear regression, we use this equation. So from here only we will calculate the logistic regression formula only, right? So and the logistic regression we calculate, but we can't use this equation, right, to get the output. But in the logistic regression, we have to calculate the probability. That is why is the probability of the given variable x belongs to certain class. Thus, it is obvious that the value of y should be lie between 0 and 1, because this in the logistic regression, this should y should cannot be anything. It will always lie between 0 and 1 because we are going to calculate the probability. Did you get did you ever get that probability of occurring any event is more than 100%? Never, right? So it cannot be more than 1. But when we use the equation 1 to calculate the probability, we would get the value less than 0 as well greater than 1. That doesn't make any sense. That doesn't make any sense. So we need to use such an equation which always gives the value between 0 and 1 as we desire while calculating the probability, right? So now how we can restrict this output? Now my job is what? Just try to understand the problem. With this equation, we will get the y value anything. It can be less than 0, it can be more than 1 as well, right? So how my job is to, we have to restrict this y to get the output always between 0 and 1. How we can do that? So we are going to introduce another function of mathematics, which is called sigmoid function. I'll talk about the sigmoid function just a while, in a while. So let me talk about this sigmoid activation for sigmoid function. In deep learning, we used to call it a sigmoid activation function, but here we are going to use the sigmoid. Sigmoid is the mathematic function if you are from the engineering background. And if you are coming from the engineering background, there is a subject called M2, mathematics 2. How many of you studied this subject like mathematics 2, M2? There is a, yeah, there is already given this sigmoid function, I think in chapter 1 or 2. I couldn't recall that part, but yeah, that this function is there. So we use the sigmoid. 1 minute, just a minute. So we use the sigmoid function as the underlying function in the logistic regression. So mathematically and graphically it shows like this. Sigmoid activation will be like this. And the equation of sigmoid activation function is equal to 1 by 1 plus e to the power minus x. X is independent. So in our case, y is equal to mx plus c was the equation. But in this case, we are going to write y is equal to, this is y. Y is equal to 1 by 1 plus e to the power x. Now let's start from here. So why we use sigmoid function? Now your question is why we use sigmoid function? Number one, we are going to use sigmoid function because sigmoid function value lie between 0 and 1. That's what we are going to use sigmoid function. The sigmoid function range bounded between 0 and 1. That's what. Thus, it is helpful to calculate the probability for a logistic function. Number two, it derivates easy to calculate then other function which useful during the gradient descent calculation. I'll talk about this gradient descent. This is the deep learning concept, but as of now, just try to understand why we are going to use the sigmoid function. Number one reason, because its value, its output lies between 0 and 1. So that it can be useful for us to calculate the probability. And it is simple way to introduce non-linearity in a model. So this seems like it's a non-linearity relationship. Can you see this? So here we have a 1 point. Can you see this point? 0.05. So if my sigmoid output will be more than 0.5, then it seems like this particular class belongs to this class. If your sigmoid output is less than 50%, then seems like your output belongs to this class, downward section. So what we can understand, with this we can, now you might ask this question, Rajesh, so then with the sigmoid function or with the logistic regression, we can solve only binary class classification problem, right? Either yes, no, true, false, male, female. What will happen for the multiple classification problem? Then I would suggest you can use logistic regression algorithm to solve the multi-class classification problem, no doubt at all. But it is recommendable, always recommendable by the researchers, not by me, recommendable by the researcher. If you have a multi-class classification problem, then don't select logistic regression algorithm. Select different algorithm, anything, not logistic regression, right? But you can use the logistic regression for the multi-class classification problems, right? So although there are other functions as well which we can use, but sigmoid is, see, so it is not like that only sigmoid activation function which value lies between 0 and 1. There is an n number of functions in the market or in the mathematics is available which output lies between 0 and 1. So we can use any other functions as well. But sigmoid is the most common function used for the logistic regression. We will talk about rest of the function in the neural network section. So when we will start a deep learning, in deep learning, we have a different function like ReLU function, ReLU, leaky ReLU, PReLU. These are the different functional logic, sigmoid, softmax. These are different functions whose value lies between 0 and 1, right? But why sigmoid? Because sigmoid is very common to use for the logistic. Okay, so did you guys understood so far? Any question till now? Say by yes, we can go ahead. You can say in the chat as well. That's good, well and enough. No need to unmute. Oh, fine. Now let's discuss about logistic regression function. So now we'll use some mathematics here. And equations are already given. No need to write in your pen and notebook. 1 minute. 1 minute, folks. Just okay, cool. Now we are going to calculate our logistic regression formula. How we have done y is equal to mx plus c. So final output of the means final function of logistic regression will be look like this. P of x means probability of x equal to e to the power beta naught plus beta 1 x divided by 1 plus e to the power beta naught plus beta 1 x. This is the final output. Let's get derivations of these things. Means how we can get it, right? So to get this, what we can do, okay, so this is our first equation. This is our first equation which we know like her. Now what we can do, we can just do one. This is our probability of x. This is our probability of x. Okay. Now what we can do, can we make this beta naught plus beta 1 x as equal to h of theta so that it will be simpler to write here. So let's consider these things. E to the power beta naught plus beta 1 x is equal to h theta. So can I write like this? P of x is equal to e to the power h of theta divided by 1 plus e to the power h of theta. Can we write like this, guys? Please say yes by the chat. Yeah. And now what we can do, we are going to subtract both sides. This is the probability of x. Now what will be the probability of y? Other like no. This is the probability of occurring an event of x. Now what is the probability of not occurring the event x? So simple, 1 minus. Yes. So P of x, this is equation 1. Sorry, you can write 2. And this is now what we can write equal to 1 minus e to the power h of theta divided by 1 plus e to the power h theta. See, everything is written, don't worry. See, everything is written here. So now if we can calculate this, we'll get the output 1 by 1 plus e to the power h theta. This is your probability of 1 minus p of x. Up to this, any doubt? Now what we are going to do, this is our equation 3. And this is our equation 1, 2. Now we are going to divide both the equation, 1 or 2, 2 or 3. So here we are just doing the division. So P of x is equal to divided by 1 minus P of x we are going to do. And now we are going to put the value. P of x का value क्या है? This one. E to the power h of theta divided by 1 plus e to the power h of theta and divided by 1 by 1 plus e to the power h of theta. These both things will get cancelled. So P of x divided by 1 minus 1 minus P of x is equal to e to the power h of theta. Can I write? So P of x divided by 1 minus P of x is equal to, can I write e to the power h of theta ka value is what? B naught plus beta 1x. Can I write like this? B naught plus beta 1x. Can I write like this? Yes, we can write. Now what we can do, we are going to apply logarithmic at both sides. Can you see this? This here, we are going to do the same thing. So here we are going to take a log at both sides. So here I'm just trying to take a same thing. So everything is written, don't worry. So here just we are going to apply the log at both sides. So यहाँ भी log लगा देते हैं and यहाँ भी log लगा देते हैं. How many of you know log, how logs work? Logs work very simple. Whatever power will be there, log of x to the power n we are going to write, then this power will come front, right? N into log of n. Anybody remember? Sorry, log of, anybody remember this part?
No.
Yeah. Something coming in your mind. That's okay. Everything will come now.
This is differentiation, right?
No, this is log. अरे डिफरेंशिएशन में तो ये होता है ना, x to the power n d of x is equal to n into x to the power n minus 1.
No, I mean differentiation for log x power n.
No, x log में whatever power you are going to write, that power will come front, not differentiation. Just check it once. So we are going to write this power will come front, beta naught plus beta 1 x, and log e will be what? Anybody remember log e what? Is 1 equal to 1. It always 1. So we can write log of p of x divided by 1 minus p of x is equal to beta naught plus beta 1 x. And the same thing has been written here. Can you see this? I'm going to rub everything. Are you guys able to understand? This is called logit function. Right? Hello? Yeah, very good. Now, now this is called logit function, right? So if it is called logit function and we can see probability and see p of x, if p of x is equal to less than 0.5, then the value of this function will be 0. If the p of x is more than 0.5 or greater than equal to 0.5, then the value of equal to 1. So never something come between 0 and 1. That's what I wanted to say here. Now let's try to understand. So what I'm trying to understand, so this is our called logistic function. Now at the end, so we understood this part, right? This is called logit function. And we'll talk about the cost method. This is called cost function. I'll talk about this cost function, but as of now, just try to understand this is only the logistic regression function at the back end they are going to use, right? So which will give the output. Okay, any question in this mathematic derivations? Let me drop these things because everything is written here. Yeah.
No.
So very good. So I'll talk about this cost function. What this cost function is? Let me explain this cost function. So I'll take one example. In hospital, everyone in today's days, everyone is trying to do one kind of test, which is called cancer test. Okay. So like 1,000, 10,000, 1 lakh patients are going in the hospital and they are going to conduct this test, like cancer prediction, cancer test. So now just try to understand this problem statement in a very clear way. Then only you guys can understand about the cost function. Okay. So cancer test may, let's suppose 10,000 patients is going to hospital in a day, 10,000 patients. And out of 10,000, only I can say 5 to 6 patients is getting identified as a cancer positive, right? Out of 10,000 patients, only 5 to 6 patients is getting cancer positive, like cancer, they are suffering with cancer. Now, what is the percentage of getting cancer? Like 5 by 10,000. Can anyone calculate this value? What is that? What will be coming like percentage in percentage? Anybody? I think 0.0002%. 0.002%. It's very rare. Now just try to understand. These things is getting done by doctor manually. Manually, doctor are doing some testing, and they are going to say whether you are suffering with cancer or not, right? Let's suppose you automated this process. Let's suppose you build a machine learning model and you deployed this model into doctor's chamber or in hospital website. Now, in the hospital website, everyone will come and they will do this testing. Like how many of you did this testing, Arogya app, like just a corona time, right? Or else there is another website which is called, I have seen, wait, there is a one website which Traya. How many of you heard about this Traya? Hair testing. Take a hair test, right? So see, here they are going to ask some few questions here, and they are going to take a photos, and based on that, they are going to check in which stage you are. Stage 1, stage 2, stage 3, stage 4, stage 5. Based on that, they are going to recommend the medicines, right? So same thing is here as well. So what will happen now? Now that hospital guy want to do this process as a automated. So people will go to the hospital website and they can do this kind of testing by itself. Now just try to understand 10,000 people were reaching to the hospital. Now 10,000 people will reach into the website. Now these 10,000 people will do their testing, assessment testing, and they will get their result. Now let's suppose your model is not well. In that case, what will I? Let's suppose, just try to understand that way, huh? Right now, you build a model, deployed into the production, and let's suppose out of 10,000, 5 is getting only cancer predicted, and 95 is not there. So if your model is able to predict this 5% cancer positive, then it's well and good. But let's suppose your model is not able to predict any single one as a cancer positive. Every 10,000 is saying not cancer positive, like no, negative result, no, you are not cancer. So in that case, what will be your accuracy? 95%, right? Only you missed 5, na? But accuracy is how much it got affected? 95%, 5%. Just take for example, just try to understand. Okay, instead of making this 10,000, I am going to make it 100, so that the calculation will be easy. So let's suppose So let's suppose your machine is not able to predict that 5% as a cancer positive. So what will be effect to your accuracy? 95%. Still, it is good model in machine learning algorithm. 95% accuracy is very good. Though for which purpose we build this algorithm, that purpose itself is not getting solved. But still, your accuracy is 95%. Is it good model? Yes. No, it is very worse model. Very worse model. Your model is not good at all. Because for which purpose we build this model, that purpose itself is not getting solved. In medical domain, this is very, very important factor. Because see, if let's suppose one patient missed to identified as a cancer, means like he or she will be away from all the medications, right? And he or she will do whatever he or she wanted to do. They will not take any kind of precautions of the cancer, right? How much blunder mistake we are doing in the medical domain, like if your model is not good. So that's what we are going to introduce, a cost function. What this cost function? Cost function, let's suppose, if you are doing mistake here, see, let's suppose you have one spouse or child or whatever it is. So what will happen? Your child is doing mistake in local exam or internal exam of the school, then it's fine. You are not going to give much punishment. But same mistake if your child or spouse is doing in your like board exam or something, like entrance exam, then in that case, you are going to make him the bigger punishment. Like, no, this is blunder mistake you did it. For this, you have to be punished, right? So this likewise, we are going to add a cost function wherever we have to add. So that's way we are going to use this cost function. Did you guys understand importance of cost functions? And why it is important? So, yeah.
Yeah.
Very good. So, yeah, and don't worry about these things. What is these things related to be? It's like a deep learning concept. Now we are going. I was talking about one thing. Logistic regression is best fit model for the binary class classification problem. What is binary class classification problem? True, false, pass, failure, male, female. This is called binary class classification. Pass, failure, binary class. But what will happen multi-class classification problem? I will not recommend you use the logistic regression for binary class, multi-class classification problem. But if you want to just do an exploration of how the multi-class classification problem works with the logistic regression, then the formula is same. Just add B1, B2, B3. How many inputs are there? Then in that case, it will treat as a multi-class classification problem, multiple logistic regression as well. Have you guys understood how the multiple logistic regression works? It's a similar way. You can use that. So now we understood the linear learning algorithm, all the sort of. Forget about these things. This is a deep learning concept. I'll talk about later. Now we are going to understand. Okay, in case of linear regression, how we were saying our model is good or not, we were doing some evaluation, and we used to use some kind of evaluation metric. Here, what kind of metric we are going to use? So what kind of metric we were using in linear regression? Anybody? To evaluate adjusted R square, not R square. Why not R square? Because there was a problem, and you guys know. So adjusted R square was the metric to evaluate linear regression model. Similarly, if you are going to evaluate classification model like logistic regression, decision tree, random forest, we'll talk about this thing. So if you are going to evaluate your classification model, then in that case, we are going to use these metrics: accuracy, recall, precision, F1, specificity, AUC, ROC. So let me give you some reference. I have created this one. Just go to this again, 5 video. This is the reference for you guys. Please watch 5 video before coming tomorrow session. This is request. I'm not giving you kind of order or something. It's just a request. Well and good. Anyways, I will explain. But this 5 or 6 video, I have explained everything. With graphical animation, all the sort of thing. That's what I wish to speak about these things. Please go with all the things. See, all metric, accuracy, how accuracies work, how F1 score work, how sensitivity and specificity work. Everything I have explained these things here. So please watch this video. It's like 7 minutes, 6 minutes, not more than 30 minutes. If you are going to watch this 5 video, just watch it. No need to remember anything. Just watch it. Right? 30-minute job it is. So you can complete this 5. Right? So yeah. So let me talk about now. Okay, let me talk about the accuracy, recall, precision, F1 score, specificity, AUC, area under curve, and ROC, RUC. It's actually not ROC, it should be ROC. It's not RUC, it should be ROC. This is okay, now let's talk about, okay, these are the evaluation metrics. I will explain this part one by one. Before that, explaining this part, I would love to talk about confusion metrics. As its name is suggesting, confusion metrics means you guys can understand how much confusion will be. So don't worry at all. I'll try to make you understand what is confusion metrics. So confusion metrics is very much important metric for any kind of classification problem, which will help you to understand how your model is behaving and where your model is getting dropped, right? So let's talk about the confusion metric in detail, and then we can jump into the accuracy and all the sort of things. Okay. With this confusion metrics only, I will try to explain all the things: accuracy, AUC, ROC, PU, all the sort of things. Okay. Before understanding the confusion metrics, let's first understand this diagram. Okay. Let's first understand this diagram, what is saying. So in this metric, there is a two thing. In this metric, there is a two things. One is called actual, one is called predicted value. So let's suppose I was talking about 100 patients went in for the cancer test in hospital, and there is a source of truth, like doctor is a source of truth, right? We can't trust on the machine, but we can trust on our doctors. So doctor is saying like 10 patients are cancer positive and 90 patients are not cancer positive. This is actual data. This is actual data, not cancer. Actual data means that is called actual data. Means true positive. Just try to understand actual positive means cancer. Yes, he is suffering with cancer. Negative is not a cancer, right? So this is actual data. Now just try to understand predicted value. Now same data, same 100 patient went to the machine. Now this time machine is the doctor. This time now machine is saying cancer 8 and 92 is saying not a cancer. Now just try to understand what is the problem here. Means either machine can be wrong, or obviously machine will be wrong, not doctor. So in that case, we are going to plot the confusion metric. So how we are going to plot this confusion metric? This side predicted value, this side actual value. If let's suppose first patient went to the doctor and same machine, and doctor is saying not a cancer. Oh, sorry, saying cancer, and machine is also saying cancer. Means doctor is also predicting same and machine is also predicting same. Then this scenario is known as true positive. Means yes, both the things is aligned. Did you guys understand what I'm saying? Means both the things is aligned. Means machine is also predicting the same thing what doctor is saying, right? Similarly, negative. If doctor is saying not a cancer, means no, you not a cancer, you don't have a cancer. And machine is saying yes, you have a cancer. Then in that case, this scenario is called false positive, because falsely identified patient is a cancer. So this is called FP, false positive. Did you guys able to understand what I'm trying to say here? Yeah, false positive. Now coming to the negative section. Now negative section mein doctor is saying you have a cancer, but machine is saying no, you don't have a cancer. Then this is also wrong. This is called falsely identified negative. Falsely identified negative. This is called false negative. Now coming to the true negative. What is true negative? I mean, doctor is also saying not a cancer, and your machine is also saying not a cancer. Then both the things is same. This is called true negative. Did you guys understood this diagram? Confusion metric diagram? Yeah. So now my question is, there is a 4 metric: true negative, true positive, false negative. Now my question is, which matrix is good for our machine learning? True positive, false negative, and true negative. Which matrix will be good for our machine learning model?
True positive.
And yes, you are
And true negative.
very good. So if any model you are building, always try to understand these metrics should always high, true positive and true negative, because these are the things, these are the two places where machine and doctor both are aligned, right? So our metrics should be in that such a way. So our model should be in such a way so that our true positive and true negative should be high. But if your model is predicting more false positive, more false negative, then in that case, you have to revisit your model and you should think about your model once again. If your false negative and false positive is very high. This is called confusion metric. Did you guys understood now? Any question in this confusion metric? No question. Okay, very good. Now, what are the things is there? True positive, I think I already explained. True positive means what? A result that was predicted as positive by the classification model, and also actually it is positive. That is called true positive. Now I was talking about true negative. True negative in the sense of as a result that was predicted as negative, but true negative. And by the classification model, and also actually it is negative, then it says like true negative. False positive means what? A result that was predicted as a positive by the classification model, but actually it is negative. Then this is called false positive. Similarly, for the false negative, a result that was predicted as a negative, but actually it was a positive. That is called false negative. Yeah. Okay. Now coming to the all matrices, what I was discussing here. Accuracy, recall, precision, F1 score, specificity, AUC, ROC. Okay. Okay. Let's talk about accuracy metric. Before moving ahead towards this metrics, I would ask one question. If you guys having any question, any confusion till now, you can feel free put on a chat, or you can unmute yourself. I can answer this question. Otherwise, I can move ahead.
Yeah, Rajesh, I have one question. I know, like you have already explained, like when we are going to use linear regression and when we will be going to use logistic regression.
Yes.
Like, based on data, how we'll be deciding which regression helps us to build the model.
Yep.
Can you explain once again in between these two, what are those differences and which we need to select for which type of data?
Okay, sure. So let me explain once again. Let's suppose you have to predict your weight. So to predict a weight, what are the different factors will be there? Age, sex, and diet or something, and blah blah, different features. And in this case, your weight will be like 35.5, 40, 60. This is called real number. Continuous data. Quantitative data means anything can come. Number can be anything. In this kind of scenario, you should use linear regression. Linear regression. What is about the classification problem? Classification problem, like let's suppose, let me take another example. Titanic data set, or you can say, or pass or failure. Like let's suppose you went for examination of JEE mains, just JEE mains. Okay, so for JEE mains, first thing is that number of attempt. This is important, right? Number of attempt, how many attempts you are taking. Second thing is that board, which board you are getting passed. Third thing, your age also matter. I believe sex will be matter. Yeah, sometime, not really, but it could be some of the feature. Now, and board percentage as well, right? Board percentage. Board percentage. Now just try to understand. These are the different feature, and now you are going to predict whether you are able to crack the JEE mains or not. Yes or no, right? Yes, no, yes, no. It cannot never be possible between yes and no. Then this kind of problem statement, if you are trying to solve, then always select classification approach, either logistic regression or different classification approach, what we are going to discuss in the coming classes. Did you guys, I think now, did I answer your question clearly?
Yeah.
Very good. Okay. And if you are taking linear regression algorithm as a model, then go with the adjusted R-square metric to evaluate your model. And if you are selecting any kind of classification algorithm, then go with this metrics, confusion matrix, true positive, accuracy, ROC, AUC, all the sort of things. Okay. Cool. Now let me talk about accuracy. Okay. So accuracy is what? Accuracy, as with this graph, I have clearly explained these two numbers, true positive and true negative, will be decide, means it should always high for our machine learning model, right? So what we can say here, so accuracy will be true positive plus true negative divided by whole is called accuracy. How much value will come, more value with this the accuracy will be high. True positive, true negative divided by total. This is called accuracy, right? This is called mathematical derivations of accuracy, right? Now on or it can be said that it is defined as the total number of correct classification divided by total number of classifications. Did you guys understood accuracy? What is accuracy? Any question in the accuracy? No question.
No.
Very good. Now let's talk about the recall or sensitivity. Okay. So recall, the mathematic formula is true positive. Just try to understand true positive divided by false negative. So recall sometimes is also called as recall also called as, see, true positive divided by false negative means total positive we have. Let's suppose doctor said 90 patients are, sorry, 10 patients are positive. Out of 10 patients, how many your machine is correctly identified as a positive patient? That is called recall. So true positive divided by true positive plus true positive negative. TP divided by TP plus FN. This is called recall. So, or in the name suggests, it is measure of both total number of positive results, how many positive were correctly predicted by the model. Same way, like you can write like this, or you can say, if your doctor is saying 10 is positive patient, but out of 10, how many your model is saying it's 10 patient is positive. Out of 10, how many your model is, how many patients your model is saying it's positive. That is called recall. Okay. And it shows how relevant the model in term of positive. Okay, now, okay, here is a one catch. So just try to understand, though your accuracy is less, sometime your accuracy will be less, but still we are going to move the model into the production. Why so? This is a very bigger question as an interview. See, in interview, no one is going to ask, write a mathematical derivation of logistic regression and linear regression. No one is going to ask this. In interview, people are very now clever, like especially product-based company, right? So product-based company or any service-based company, they used to ask very relevant question. Though my accuracy is good, but still I'm going to move my model into production. What is the reason behind it? So here is the question. Here is the catch here. See, accuracy is not only metric which we are going to take for decision of model put into the production. Accuracy is just one of the metrics, I can say, but it is not only single metric. So there is a multiple factor. In your business use case to use case, it gets different. In your use case, let's suppose you are fintech company. You are going for the fintech company. In fintech company, if some money, let's suppose in fintech company, some money by mistake is going to credit to company account, that is fine, because we can reimburse to the customer. But some money by mistake is going to the customer account, that is very hard to get back. Did you guys understand what I'm trying to say? Some money is by mistake is getting deducted from your account, that is bearable. We can reimburse. If someone is claiming to the bank, then we can reimburse. But what will happen by mistake, some other money, let's suppose I am sending you 100 rupees and by mistake means it's phone pay problem that it went to the 1000 rupees to your account. You are happy, but machine, but company become loss, right? So this is not acceptable because there is no control of the company to get back that money because PhonePe is just a merchant, right? To make a transaction between your bank and the customer, right? So in this case, we cannot bear this second part, right? But what will happen? 100 rupees you are passing, sending to me, and out of 100, 90 rupees is going to your account and 10 rupees is coming to the PhonePe account. Then it's bearable. It's a mistake. Then we can reimburse this money to you or to you, either of you. So depends which kind of problem you can bear, your company can bear. So in case of medical domain, for this recall cannot be less. Means if 10% is saying positive, then your model always say 10% positive. 99.9 also not acceptable Because see, if one single patient you are leaving, means how much blunder you are doing the mistakes. Like that patient will never get the medication, proper medications, right? So this is the thing. Did you guys understood? Now, but let's suppose by mistake your model is saying positive, means though that patient is not positive, but your model is saying positive. It's bearable. What will happen? Second attempt, means let's suppose your machine is saying positive, then what will happen? This patient, let's suppose this is the patient, is marked as yes, you are cancer positive, for instance. Then this patient will go to the doctor, and doctor again do manual testing, and in that manual testing, he will get marked as not a cancer. So this is not a mistake. This can be bearable. Sorry, it's a mistake, but this can be bearable. Did you guys understand? So this can be bearable, means if your machine is doing this kind of mistake, then it's bearable. It's ready to move into production. But still your accuracy will be less in this case as well. So that's what I'm saying. Accuracy is not only metric with which you can take a decision. Accuracy is just one of the metrics, I can say. Right? So recall, that's what I'm saying. Based on the problem statement, problem to problem, your matrices, means your model performance or model matrices, evaluation matrix is getting important. Did you guys understood now? If in interview someone is asking this kind of question, will you able to answer this way? Yeah. Very good. Now just try to understand. Recall we understood. Quickly we can wrap it up. Recall we got it. Now precision. So precision is another matrix. Precision is a measure of amongst all the positive prediction, how many of them positive prediction. This is also called true positive rate. Let's come into this graph and you can see all of positive prediction. This is our positive prediction, this section. So out of all positive prediction, how many are actually positive? That is called precision. So precision is the measure of amongst the all positive prediction, how many of them are actually positive by mathematics. Okay, so this is called precision. Now we are going to understand. Okay, we understood these three metrics, right? Precision, accuracy, recall, precision. Now we are going to understand F1 is called specificity, AUC, ROC. Okay, yeah. So let's talk about the problem. We have a problem that as evident from, okay, what is the problem? Just let me explain this problem first. So how many of you remember this graph? Just now I have explained, right? Sigmoid activation function. In the sigmoid activation function, we kept a cutoff region, or you can say threshold region, as 0.5. If your probability of any event is coming more than 50%, then we are going to mark it as a this class. If the probability of certain event is coming less than 50%, then we are going to mark it to a different class. This scenario is pretty much clear. This picture is pretty much clear. Now my question is, who have decided the probability cutoff is 0.5? This I told, right? Now, in every use case, this 0.5 is not only will be the threshold. This is the hard-coded threshold we kept, but it can be anything, right? It can be 0.4, some problem statement, 0.6 will be the cutoff, 0.7 will be the cutoff, right? Like in IIT or UPSC exam, the cutoff, you might listen, the cutoff will get vary with the number of student and with the question, the cutoff will get vary. Some PSC cutoff is around 80%. Mechanical cutoff is 50 to 60%. Like cutoff value is getting changed with the time, with the problem statement, right? So who is going to decide, right? So for that, this is the bigger problem. So problem is not as evident from the previous example. The model had a very high accuracy, but performed poorly in terms of the precision and recall. So necessity, accuracy is not a matter. Okay, I already explained this part. Accuracy is not only the metrics for this. Imagine the scenario where the requirement was that the model recalled all the defaulters who did not pay back the loan. Suppose there is a 10 such defaulters and the recall those 10 defaulters are the more gave to the 20 results out of which only 10 are the actual defaulters. Now the recall of the model is 100%, but the precision goes to the 50%, right? So this way we can easily mark it out what model is important, what metrics is important. Now I want to talk about trade-off graph. Trade-off graph, why trade-off graph? To get this value, this cutoff. How the trade-off is working? As above from the graph, with increase the recall, there is a drop in the precision of the model. So the question is what to go for, precision or recall? Well, the answer is depend on the business requirement. If your business is geared to take a positive risk or negative risk, some company is ready to take a positive risk. Like in medical domain, we can't take the positive risk. We can take the negative risk. Sorry, we can take the positive risk. Like let's suppose your model is saying yes, you are a cancer, but it's not actually cancer. Then we are ready to take this kind of risk, right? But if your model is predicting negative to the actual positive cancer patient, then it's a mistake, right? So it depends on the business requirement. So for example is already given. So this confusion, in order to clear this confusion, we are going to come up with the another matrix which is called F1 score. What do you mean by the F1 score? F1 is the harmonic precision HP, AP, GP, HP. I think you heard about this term, right? AP, GP, HP.
Regressions.
Yes. So it's a like a H. हाँ, कुछ बोल रही हूँ like Primula?
Yeah, it's progression.
हाँ, it's a like sequence. So HP, we are going to calculate the HP of precision and recall, and we are going to calculate this F1 score. So it is a combination of both the things. So if you are getting confused between precision and recall, calculate the F1 score and then get the score. If your F1 score is high, means your model is good. Any questions? No question. Now we are going to discuss. Okay, anyways, in detail, I have explained in this playlist. Please watch this playlist one by one so that the things will be much clear, very much clear. Yeah. Now I'm going to talk about the specificity or true negative rate. What do you mean by the true negative rate? So very important and very important. It will be useful for your AUC and ROC as well. So this represents how specific the model while predicting the true negative. Mathematically means how true negative in the sense of, let's suppose, come to the confusion metric. Again, draw this confusion metric in somewhere in your bedroom or somewhere. I used to draw. I have my in my bedroom. So this helped me to solve many problems. So true negative rate, since specificity is what? True negative rate means specificity is also mentioned as true negative rate. So true negative rate means what? Just try to understand. Out of whole negative, this is my complete negative. How many actually got identified as a negative? That is, so means Tn divided by Tn plus Fp is called true negative rate. Tn divided by Tn plus Fp is called true negative rate. Now coming to the ROC and AUC. Okay, any question specificity? We are going to calculate a true negative rate. Okay, so now we are going to understand ROC, receiver operator characteristics. What do you mean by this ROC? So we know that the classification algorithm work on the concept of 1 minute. No? So what I was talking about this ROC and AUC, right? So we know that our classification of logistic regression work on the parameter of what? Based on this cutoff region, right? Based on this cutoff region. Cutoff in the sense of what I'm trying to say, that like that 0.5. So who is the owner to take this decision? That decision we can take behalf of ROC. ROC in the sense of what? We are going to calculate our ROC graph between true positive rate and true negative rate, and then we are going to take a decision whether my ROC, what will be my absolute threshold, right? What will be my absolute threshold? Just a minute. Okay. So we know that the classification algorithm work on the concept of probability of occurrence of the possible outcomes, and a probability value lies between 0 and 1. 0 means is that is no probability or of occurrence, and 1 means is that occurrence is certain. But while working with the real-time data, it has been observed that we seldom get the perfect 0 and 1 value. Instead of that, we get the different decimal value lying between 0 and 1. Now, the question is, if we are not getting binary probability value, how are we actually determining the class of our classification problem? There comes the concept of threshold, which I talked. A threshold is set any probability value. Below the threshold is negative outcome. Anything more than the threshold is favorable or positive outcome. For example, if the threshold is 0.5, any probability value up below 5 means negative or unfavorable outcome, and any value is above 0.5 indicate the positive or favorable outcome, right? So now the question is, what should be the ideal threshold? We used to keep this 0.5 from the long time, but I'm going to make this thing correct now. We are going to get that 0.5 value, actual 0.5 value, right? So for that, we are going to draw a graph, and graph in the sense of what we are trying to draw the graph. We are trying to draw the graph. The following diagram shows the typical logistic regression curve. So the horizontal line represents the various value of the threshold range between 0 and 1. We are going to make a horizontal line, and that horizontal line we are going to keep the different threshold. Like first we'll take 0.5, 0.6, 0.7, 0.4, 0.3, like this we are going to draw. And let's suppose the classification problem was identify the obese people from the given data, and the green marks represent the obese people, and red marks represent the non-obese people. Like it's like cancer positive and it's kind of binary classification. Our confusion metric will depend on the value of the threshold chosen by us. For example, if we choose a 0.25 threshold, means true positive is equal to 3 and true negative is equal to 2. False positive is equal to, false positive not obvious, like this kind of 0.25, false negative. So what we are going to do, we have selected the threshold as 0.25, and now we got the confusion metric this. Now we are trying to plot a graph between the true positive rate. You know what is true positive rate? Out of whole positive prediction, how many correctly identified as positive? And true negative similar. Out of all negative prediction, how many are you are able to correctly identify as a negative? So we are trying to plot a graph between the true positive and false positive, and we will calculate this graph like this. Okay, we have a this kind of graph here. Now just try to understand at a different threshold we are going to calculate true positive and true negative rate. Now after a certain point we can see this line is becoming a straight line. Can you see this? So this point is going to mark as that particular threshold. Let's suppose this is that particular threshold, and this is the optimal point of threshold where we are going to mark. This should be our threshold. Did you guys understood how we are going to calculate the actual optimal threshold to get the prediction? Means what I'm trying to say, just try to make you guys understand very clear. Let's suppose first we assume the threshold is 0.25. Like this, we are going to calculate TPR, and how to calculate TPR above we mentioned. FPR, we are going to calculate. We'll calculate and we'll plot the graph. 1 point repeat. Similarly, we'll make another threshold. Threshold is equal to 0.35. Similarly, we can calculate a TPR, FPR, and we'll plot this graph. We'll come to like this 0.35, 0.75, 0.85. And we'll get some point where the after this threshold, whatever threshold we are making, our line is coming as a straight line, horizontal line. Then this condition is known as what? Optimal threshold, right? Did you guys understood how we are going to do? Oh. Yeah, and everything is mentioned here. Can you see this? All the things, right? and Python implementations. Now Python implementation I'll talk about in the next class, but this is more about the theoretical concept of all the classification of it. Yeah, that's all for today. Any question in this? No.
Give one assignment on Python.
Yeah. So logistic regression I have not talked, but linear regression assignment, please try to complete and submit by before coming the next class. If you have any question, then feel free to ask over the channel. So I would love to answer those things. Okay. And by the way, instead of WhatsApp channel, I have my own Discord channel as well. So please refer that Discord channel. So this is my Discord channel. So you can ask the question here as well. So please try to address your question here, because here is the great community. Many people has been joined in this pipeline. So anyone can give you the answer. You should not depend on me, right? Right, guys, please do join Discord and try to mention all the kind of question, whatever question you have, 24/7. I'm ready to answer. Even community is ready to answer your question. Okay. Cool. If you there is a no question, I can wrap it up for today. Yeah. Fine. Thank you.
Okay.
Thank you. Thank you so much.